I forgot to record. I'm so sorry. So we are doing some revision on the chemical properties of group 17. Okay, so we add water, we get 2 acids. Okay, 2 acids. So when we add sodium hydroxide, which is alkaline, now I will get 2 salt. But that's not done yet, because the salt, we take out the H already, right? All right. We also will react with the OH here. The H and the OH will form water, H2O. Get it or not? Because just now we only replaced the Na into the hydrogen. Can you see? So the OH and the H go where? There, form water. So this is sodium chloride, sodium hypochlorite, and water. This is the third formula. Okay? So now I'm going to test you all and see whether you can write the formula all or not. Okay? I'm going to go to the next page. Okay. Right there, group 1 and 17, chemical properties, and write down today's date, 17/7. I got 8 formula for you all to do. No referring, Okay, so I will start with sodium. I got reaction with water. Tell me what will it form? Chlorine also react with water. Okay, chlorine too easy already. Just now we just did chlorine, right? So I'm going to change to bromine, in fact. Jamie, 做功课. Then now I take lithium, react with oxygen. Okay, burn in the oxygen. I take iodine, react with iron 3. Don't forget, positive must write in front. Don't write negative first.你算要快点好不好？回次来这个，这样做完。Okay, next, lithium we do already. Now I do potassium. Reacts with bromine, halogens. Number 6, I want iodine. Now I'm going to throw it into water. Okay. Last 2, I want chlorine, reacts with sodium hydroxide. And when the iron 3 reacts with bromine. I got 8 questions here. Everybody do. And you have to actually send it to me. Understand? Okay? You have to send it to me after you balance the equation. So when you copy, please don't, you see or not, I purposely leave some space so that I can write and balance the equation properly. Can Ziyi? Try, Okay, good job. Don't understand what to do? Tell me. I want to know. So these are the only equation, seriously, very important for this chapter, talking about periodic table. The rest, right, not so important one. Don't worry. Today I teach you period 3, all those are not as important as this one. So basically, there's only 6. 3 from group 1, 3 from 17. Okay, they will only ask you this type. Even the period 3 one, they won't really ask one. It's just for your information only. So I won't emphasize on those. Okay? Got 8 questions. From now onwards, I give you until 6:05. 6:05, you have to send your answers to me. Balance the equation, huh? Do now? Don't see your notes and do, okay? Try to challenge yourself. Think back what I just did. Wow, so fast, Weng Li counting already, you know. Can you imagine? She only used like 2 minutes.
Teacher, may I know what is the question for number 3, 4, 5?
What you cannot see?
I don't know.
You mean there's nothing there? Empty space? Really? See? So weird, no? You take a photo, show me what you see. I'll send you one. The rest of you can see or not? Is it the same problem? Yeah, Chin Kai can do. Chin Kai, you never balance equation. Check number 7. Connection error. You load, you go out and come back again, can try see. I scared later when I share screen again, you cannot see. Okay,
Already, and it's the same.
it's the same.
Yes.
Oh, okay, because I can't get out now, but anyway, I send to you already. You do first. I hope the next time I share screen, you can see. That's very good.
Can you stop playing?
Qing Yuan, I think you got it all correct. Well done. Balance equation for number 7. And also number 4 is wrong, Clara? Try again. Okay, Winnie one is okay. Good, Jessie. Jessie can do, 很好. Your plus sign, and number 2, you terbalik the OH. Where got OH one? HO, hello? Acid start from H. Yep, good job. Okay, so far those that I call your name, you can raise hand. Okay? Let me see. Clara, Zexi, Jingyuan, Qing Kai, Yanxing, and Wing Li can raise hand. Ziyi, you can raise hand.
Yes.
Kaylin Liu can raise hand. Kaylin, you must think that particular metal is metal or non-metal, group 1 or group 17. You cannot just blah, write down like that only. Okay. I'm still waiting for the rest. You never send, I cannot call your name. Then I will wait until the last one. You got 4 more minutes, last 4 minutes. 等一下你就爱睡了，因为你打球了，你很累。我叫你快快有精神的时候做完它，做完了你就等一下你做什么我都不管你。写出一件可以说明阿利普已经长大的事情。What makes you think that he will grow up？长大？为什么阿利普后来让姐姐牵着他的手越过马路？因为他需要拉他的手过马路，你明白吗？一个是他已经长大，是因为他可以自己做什么东西。第二，他为什么还是让姐姐牵着他的手？You read the passage or not? You don't know, then you take Google Translate. Go and do it. Take photo, translate it. If you don't understand the whole passage. Okay. A, B. Why you got a lot? Don't know. You must think it's group 1. What will happen? Group 17 is acid. What will happen? What is the 2 acid? Sing Hong, your battery no battery, right? Correct? Okay. What I want you to do is I want to spotlight your answer. Can you put on your screen? I will take a photo. Never say die one for teacher Joyce. 等一下啊。Go to your left, go to your right a bit. Okay, don't move now. Stop. Okay. I sent to you already, okay? So that I can do a check. Real, where's yours? Kaylin, I told you just now, group 17 got 2 types of acid, right? If 2 acid, I pour alkali in, I'll get 2 salt and 2 water. Can you balance the equation and do properly? Yours wrong already. Okay, Josh, you can raise hand also. Good. Karen, Mengi, I wait for you. You go toilet first. Okay, AB. You raise hand. Kaylin, okay. I'm waiting for Jaden, Wan Xuan, and Iril. Kaylin, yeah, okay already. I checked yours already. Okay. Last 1 minute, everybody. You don't send later. After class, you stay back, because I want to talk to you. If you still don't know, I'm going to teach you personally. So that's why I want you to stay back. Okay, time's up. 6:05 already. I already said time until 6:05 only. You want Shen very kiasu, 6:05 ngam, she will send over. Put the O in between. H and OI, put in between. If it's HCl, it's HOCL. HBr is HOBR, Wan Shen. And then why the R suddenly capital letter 1 in question number 2? So funny one. Jaden can master group 1, but Jaden cannot master group 17. It's like totally don't have in your brain. So we're going to do again. Iril, not bad. But a lot of formula you write wrongly because I think you loop already. Just now when I do revision, I think you haven't come in yet, right? Am I right? Okay, come. So I want you all to see this. I'm going to put down all your hands. You all take out a red pen now. Really? Take out a red pen? Okay, so see this, how I do, everyone listen. Don't worry, you can mark afterward. So when I see sodium, I know it's group 1. Group 1 is alkaline. When I put in the water, I remember the video teacher Joyce showed. Remember a hissing sound? And when you test litmus, it's alkaline. So what you will get? You'll get sodium react with hydroxide. Because I say water is always hydrogen and hydroxide. And if you see Na is positive, this positive will react with the negative. Can you see that? So when positive react with negative, who is left behind? See? Only hydrogen. But hydrogen cannot be H+. It must be a molecule which is already stabilized. Clear? Okay? So when you see like that, now we balance equation, okay? We balance, we write Na1, Na1. H got 3, you know. So odd number, even first. Put a 2 for H. So I can put a 2 for 4 hydrogen. 2 oxygen, 2 Na. Put a 2 here. Done? So if you write these two correctly and balance correctly, you give yourself 2 marks. I'm going to ask you to calculate all the marks for me. Okay, now you mark. Anything wrong? Use a red pen and write it. Today don't know, never mind. Cannot be next week also don't know. Next month also don't know, right? Yeah. Okay, next. If you see bromine, bromine is group what? Don't write on my screen, please, whoever it is. Okay, bromine is a acid, right? Bromine is group 17, right? So if I put acid, I put water, we will see 2 types of acid. I told you guys, it's always acid, write H first. H, take the Br one. So HBr. Acid always start with H. Why we all will write the H at the back one? I don't understand. The other one is HO, add the O in between, Br. See that? Hypobromous acid. So 2Br, 2Br. 2H, 2H. 1O, 1O. No need to balance, also get 2 marks. So easy. But if your formula is wrong, then wrong. You get 0 mark. You won't get the free 1 mark, okay? Okay. Then we go to number 3. You see lithium and oxygen, you only form lithium oxide. Lithium oxide, very simple, very straightforward one. So lithium is Li plus, oxide is O2 negative. What do? You take the 2 down, 2 chin, you take the O here, 1. So now you balance equation, no? 2 oxygen, I must put a 2 for oxygen. Can you see? So 2 times 2 is 4. 4 lithium. Balance equation, 2 marks. Okay. Number 4. Don't write wrongly. I told you the iron is 3 positive. Iodide is negative. Of course, we write the iron first, right? Then you write the iodide. But this time, you put the 3 at the bottom. I used to have my niece, her name is Fei Fei. So I always tell the father, oh, I found a formula for your daughter. Fei Fei is FeI2, iron 2 iodide. Her scientific name, I say. Cute, right? Yeah, you can go and invent something like that. Okay? Now, so this is iron 3. Now, how do I balance equation then? I3, right? Here is I2, right? 3 times 2, 2 times 3, oh? Then iron becomes 2, you have to put iron 2. Again, if you balance correctly, give yourself 2 marks. So potassium bromide, K plus, Br negative. KBr, right up. Don't put a 2, Then now only you balance the 2 for the Br, 2 for the potassium. Like that, you get 2 marks. You need to balance correctly. Okay, then when I do this, see what I'll think, I'm thinking out loud, you know. I imagine I'm Form 4 now, I do this question. Iodine, group 17, okay, acidic. So I'll form 2 acid. Okay, the first acid is HI. Second acid, teacher Joyce said, stuff the O in between. Stuff the O in between. H-O-I, and everything must be in capital letter. 2H, 2I, 1O, all balance. Ding ding, 2 marks again. Easy, right? So I don't know why is it so difficult for you. So when we practice like this, every week, you will see you improve a bit. Now, last, we take acid, reacts with alkaline, correct? NaOH is alkaline. So when you do that, what you will see is you get salt and water. Because you already in your brain, you know, hey, chlorine is acid. Sodium hydroxide is alkaline. Did you just say we'll get what? Salt and water. And because we know we have 2 acid, I will have 2 salt. Okay, no problem. Another is NaOCl. Bye-bye. Can you see that? So we have 2 acid, HCl, now become NaCl. HOCl now become NaOCl. Can you see that? So now because of 2 Na, I got 2 Na. 2 Cl, I already got 2 Cl in front. Right? 2O, I also got 2O there. 1O here, 1O at the back. 2H there, 2H already balanced here. 2O, 2H. Can you see? You got a balance for everybody. So that's how you get, number 2, you get extra 1 more mark. So you get 2 marks like that. Okay, continue, iron 3 bromide, right? So FeBr3. Again, 2 times 3, 3 times 2, 2 Fe. Done. 2 marks. So over 16, what you get now? Type on the chat for me, everybody. I know we have a few who is perfect. Yes, thank you very much. I can see your hard work. Who are they who get all perfect? We have Jing Heng. Is it Jing Heng? Jing Heng, no. Jing Heng get 14. Ching Kai, I know perfect. Ching Kai, Yan Xing, Clara. Okay. Xing Yuan. Okay. So those never get any extra marks, cannot do well. I hope next week can do better lah. Next week I will add lah. Okay. Do different. I will do 10. Oh. Okay. Good. Send to me. I'm recording all these so that I know your results. Yeah. So Ariel, now you get it or not? Better or not? Yes, right? Yeah. So if you don't know, you watch back recording. You watch back how teacher Joyce explained how now I know already. Cannot be this week don't know, next week also still don't know one. 你要走了。桌子有这几题，你回去做啊。OK， 你先走啊。OK， 拜拜。OK， now we start. Okay, last week I teach about period 3, correct? Okay, I'm going to ask Wan Xuan. Wan Xuan, can you tell me who are the members in period 3 from left to right? Read me everything. Na is who? Please tell me the name. I don't want you to say the formula. Na is who?
Sodium.
Okay, sodium. Magnesium.
Aluminum.
Good. Aluminium.
Silicon.
Silicon. Sit down and play PS. P is what?
Phosphorus.
Phosphorus. S.
And chlorine and argon.
Sulfur. Then chlorine. And last.
Argon.
Very good. Well done. Okay. So if you all look at these notes that I already asked you to copy, I actually send the notes to you all, right? Remember? Look into our So when you all find from WhatsApp, you just type 2024. 2024, then the answer, my test tube will come out. Find the test tube one. Okay? So last week, you all finished at this slide in the class. Then I gave you all notes to copy notes until semi-metal, but I haven't discussed yet one. I discussed halfway only, correct? Okay. Last week, who never come on? All raise hand. Raise hand. Let me know who never come last week. Absent. I think the two Kaylin also not in class one, right? Missed out the class. Did y'all watch the recording? No, not yet, right? Okay, very good. Who else? The rest here, huh? Okay, good. So let me explain this one more time. All listen, huh? So you see, right, from left to right, the size decreases. That means when I draw, I get smaller. But you must understand, okay, all of them are having the same 3 shells. Okay, it has the first shell, we have the second shell, we have the third shell. But how come the size keep on getting smaller? Okay, so the explanation very simple. All have 3 shells, but inside the gravity is stronger now. If the gravity is strong, I pull all the shells, they get closer to the nucleus. See that? So you must start talking about is what is inside the nucleus. Inside the nucleus, we have lots of proton. Proton charge positive, right? Not? Electron outside is negative, right? So when we increase the electrostatic forces, whoa, the force is strong. I pull all of you nearer to me. See? So the valence electron now, the most outer shell, is pulled closer towards the nucleus. And therefore, causing the radius to be smaller, decreases. Understand? So when we cross, you will see what? Sodium is 11, right? Magnesium is 12. Aluminium is 13. So when we cross until argon is 18. That means inside this nucleus got 18 proton. It's going to attract more and more. And they are closer now. So although when we cross the period, right, it's the same. Tomorrow we continue. Jirayu, pack your things. Yeah, tomorrow we continue. Okay? Now, next we go to electronegativity. Now, very simple, I say this concept. Na is positive, right? When we see chlorine is Cl negative, correct? Not? So that means here is more negative, right? So of course, negativity increases, law. But that's not the way we explain. That's for you to remember, so that you remember left to right. Electronegativity increases. Now, I can have a K-but question. Okay, it means high thinking skill. Just change the word. I don't want to use electronegativity. I change to electropositivity. Can or not? Can. Means what? Decrease law. Here is more positive, ma. Right or not? So in a very simple mind to think, this is how Teacher Joyce teach you how to memorize. But to explain it, let's see this. When I say electronegativity, you all must remember electrons charge negative. I want more electron coming in. Of course, I have to attract it in, right? So if my size is smaller, then the nucleus and the outer shell, also the distance is smaller, right? Isn't it easier for me to attract 1 electrons? Right or not? So higher tendency to attract 1 electrons. And that's how we explain electronegativity. But for electropositivity, how to become positive? So see, you tell me how to become positive if I'm an atom lah. How to become positive ion?
Throw away 1 electron.
Yeah, release 1 electron. But the smaller I become, the stronger the nucleus holding on to me, you know. Can I throw electron? It's very hard. Can you see that? Can you feel it? So you have to feel chemistry. Chemistry is something why people say, oh, love is like chemistry. Why never say love is like biology? Because you cannot see it. These are the forces that happen in the real world, and we have to feel it. And when I let you feel it, you must really be in my class, be with me, not the mind somewhere else. Then cannot imagine. Then whatever I say, right, just throw into a rubbish bin. What a waste of time. You're sitting in front of me and not paying attention. Then you have to go and study again by yourself. What? You're here because you don't have to study again. I'm here to help you to study. Okay? So everybody, put your heart in it. Okay. So last week, remember, I was checking very detailed and see how you actually copy this slide. Now, so for Caitlin, the two Caitlin, you know what I asked them to do? I asked them, hey, all do this, very high one, put explosion like that. Here, put increase. Here, put decrease. You just remember the mountain go up until silicon, the silly one. Okay, the silly one will have all the extraordinary, right? Okay, a lot of energy one, right? Okay, then you come down again. How do we explain this? How do we talk about this, right? Okay, so remember, when we talk about the first three, they are metal, right? They are metal, right? So metal, I'm going to explain now. Listen. Last week I never explained so detailed. Look now. If I am sodium and A plasma, so the sodium will throw away one electron. This sodium, throw away one electron. This sodium, also throw away one electron. Now I go to magnesium, okay? Magnesium is Mg2 plus. So magnesium throw away 2 electrons. Another magnesium throw again 2 electrons. Another magnesium throw again 2 electrons. Now we got 6 electrons wrapping around them. Okay, now I draw aluminium, okay? Al is 3 plus, right? Correct? So everyone throw how many electrons? Let's ask Josh. I cannot hear you. Each of the aluminium throw how many electrons? Cannot hear me? Say lo. What happened? No sound.
2.
Test your little arrow. Okay, now can. Each one throw how many? Al3 plus? No sound again.
Is it 1?
Al3 plus. If I'm an atom, right? Atom is neutral, right? No charge, right? But I tell you Al is 3 positive. Means I must throw away how many electrons? Cannot be 1, ma. Then 1 is here. Look. Na plus, throw 1. Na plus, throw 1. Na plus, throw 1. Mg2 plus, throw 2. 2 plus, 2. 2 plus, 2. So Al3 plus throw how many? I don't know.
3.
My standard 4 in front of me also answer already. Okay? So 3 electrons, 3 electrons, 3 electrons. I got 2 more. You have to imagine, you are sodium, your attractive force, okay, to melt, this is, imagine a tub of sodium, this is a tub of magnesium, and it is a tub of aluminium, okay? The force is between, metallic bond, is between who? Is between the electrons and the positive in the nucleus. And imagine every electron and the positive got an attraction, so many attraction in aluminium, can you see? So many attractive forces, right, around, right? But sodium only a few. Sodium only a few. So by right, aluminium should hold stronger, right? Correct? And feel, right? Yeah. And when they are stronger, you need to melt them. You have to increase your temperature so they can break this bond. I want to break it so that they become liquid. I need to break it. Wow, I need more energy. So really, you know, to melt aluminium, the melting point is about 2000 degrees. 2000! Your air fryer maximum is 200 only. This is another 10 times higher. Then only can melt aluminium. So some people, they are not studying chemistry one. They say, teacher, I put aluminium foil inside inside my air fryer to fry thing. I will be eating aluminium, Hello. 10 more times lah, it will melt. Right? Don't dream lah. See, learning chemistry, learning science, isn't it amazing? Right? You don't understand all these funny thing, right? You know how to do?
Just fine from here.
Correct. Good job. So understand? So how do you explain that? You just have to say that the metals have strong metallic bond. As we go across the period, the metallic bond increase the strength, stronger. So therefore, you need more heat, right? More heat means higher melting boiling point. Get it? Understand? Okay, I want you to draw this. Draw this at your notes. Draw what I drew. Sodium one, everyone draw 1 electron. Magnesium one, draw 3 electrons. Aluminium one, wow, draw 9, right? Correct? 3 times 3, 9. Yeah. So that you remember why you have to memorize. You don't have to memorize things. Okay, everyone okay? We know what you're doing, right? Okay. So you know, right, guys? Silicon, what do we use silicon for? I show you, okay? If I just Google, I type Google image, silicon. I show you, okay? Done or not? All done? Okay. See here? I type silicon usage, can use for semiconductor. A lot of our hard drive inside our motherboard got lots of silicon. Okay, it's a microprocessor chip. These are the chips, and they are using silicon. This one that I'm pointing to, okay, you can see it's like jelly, you know lah. And you know what people use it for? Oh, they also use it for to make higher cheekbone, put the silicone inside. Do what? Do what? What we call that? Don't know. 整容 you know or not? All those Korean girls look so pretty, why? They really go and do all the add lah, dear lah, take this out lah, correct? Ayo, you all don't know only. You think all so pretty, right? Silicone also used to make as a adhesive gum, right? And then we also use application, you can see here, all the mold that we use for baking, right? Silicone rubber bands. Nowadays, we also use silicone as rubber bands. There are so many things today in the world that we are doing today, we're using. And silicone can be as soft as this, can be as hard as a microchip. It is so versatile. So good because of the characteristic. So if you look at this, it's because silicon has a strong covalent bond. We call it a 3D gigantic network. Okay? And if you look into this again, I show you silicon. We will call it a molecule because silicon is all tied together. And this is how silicon dioxide looks like. You know what silicon dioxide? Silicon dioxide means sand. You see the sand, so hot, shine, right? Will it melt? No, it never melt. So see, silicon structure is a 3D, 3D gigantic structure, you can see? Yeah, so it is very stable. It has a characteristic like diamond like that, but diamond is stronger lah. Diamond is a also 3-dimension, and we call it tetrahedral. So if I tell you silicon is tied like this, I want you to draw it down. Here also got one. Here also can have one. Here also can have one. And imagine we have another one here. You will tie to this one. Have another one. Have another one. And the top has one more. See? So it's all 3D. Very hard to break it on. So you want to break it, right? Walao, must have very high melting boiling point. Understand? Clear? Okay. So when we go after silicon, guys, it will be all the non-metals. These, when we talk about non-metals, we are talking about van der Waals. Did you Joyce say what? Van der Waals seems like a piece of magnet. The feeling of magnetic. Two magnets put together. Oh, I don't have magnets here. If I got two small magnets, right? You imagine I break it very easy, right? Correct? But if I have two big pieces of magnet, now I got to separate it, I need more energy, all right? So when we know we cross from left to right, the size always gets smaller, right? So the magnet gets smaller means weaker force law. So that's why at the end, you see the energy, the melting boiling point is going down. So it has a weaker van der Waals force because the size does matter for van der Waals. Van der Waals is all about surface area. Between two molecules, how much they are attracted to each other. So the feeling for you is, yeah, two pieces of magnet. The bigger the piece, the higher, the stronger they will attract, the harder you're going to separate it. That is van der Waals. Of course, you can't write like that. Or you cannot just say van der Waals is like a magnet in exam. So, but you feel it, right? You understand, right? Yeah, so you just have to explain. Between a non-metal and a non-metal is always van der Waals. Clear now? Okay, so we're done with all the first part here until melting boiling point. Now I go to nature of element. So this very high one, you can continue to draw this cloud here, is called metalloid. So before metalloid is metal, after metalloid is non-metal. So this silly one, okay? Okay, let's see why. So we change because of the electronegativity increase. They become more negative. So metal is always positive. Non-metal is always negative. So because electronegativity will increase, the element will change from metal to non-metal. Easy, right? Correct? Okay. So now we go back to this. You see the formula of oxide. Okay? So we know Na plus, O2 negative. Okay, let's tukar chin Na2O, correct? Mg2 plus, O2 negative, MgO. Al3 plus, O2 negative, Al2O3. Until silicon. Okay, silicon is group 14, 14. If I were to tell you it's 4 plus, oxygen is O2 negative, you tukar chin, you get Si2O4, correct? Okay, then you simplify it, SiO2. You can still do until here. But after silicon, I'm so sorry, you cannot tukar chin anymore because these are all molecule. Okay? You know silicon, you know sulfur dioxide, SO2, but you don't know the others. So you need to memorize this one and the last one. Phosphorus oxide and chlorate, we call it. Chlorate. It's a different formula. But it doesn't come out in exam one, you don't worry so much. Okay? Now, the last one, there's no, because they don't react with anyone. How to combine with oxygen, right? So none, no? There's no compound one. Okay. Then remember I asked you all to do something? I said, hey, can you all highlight the A here for aluminium and A here for amphoteric? Because only the amphoteric happens to this aluminium oxide. Okay, let me explain. Usually, when we say basic, it means base. Base is solid, and when I put it in the water, they call themselves alkali. That is in liquid form. Base is more solid, alkali is more liquid. Get it? Okay. The others after amphoteric is all acidic. So what is amphoteric, right? Correct? Okay, so if we look at this, metal oxide, these two fella is considered as alkali or base because when they react with an acid, they form salt and water. Means, guys, if this is acidic, this guy must be alkaline, right or not? Otherwise, how to neutralize? Get salt and water, leh? So again, the properties of oxide is based on the process called neutralization. Understand? So if A is oxide, I tell you already, oxide is alkali. Okay, this is alkali one. It reacts with acid, or it will form what? Salt and water. So if you see the other one, if it's acidic one, starting from silicon all the way until the chlorate, right? I don't care which one. I simply throw in. I know sodium hydroxide is alkaline, but I still get salt and water. Means who is in front? If I tell you who is X, oh, teacher, I know X must be an acid law. Right or not? You get it? Yeah, because objective question, they give you something like that. They say X, Y, Z. One can react with acid, one can react with alkaline, one both also can react. So who is the both? Amphoteric law. You understand? So I tell student, like acidic is like boy, or alkaline is like girl, right? Correct? And this amphoteric is bondan lah. You know? Hey, look at the body, looks like a man, right? But wear the baju looks like a girl, right? Both also can one. Can you see that? So it can react with both acid and alkali. Again, they will form salt and water. See the acid and alkali? This is nitric acid. This is alkali, right? They both form salt and water. Can you see that? So this is what amphoteric is all about. It's in the middle one, remember? Okay? Between the acid and the alkaline. So far clear? Okay, any question? I stop talking first. Your turn. Anyone want to ask question? Okay, the only thing I think Kaylin, I didn't add you into online class. So the notes that I sent, maybe you didn't get yet. I add you now. No question? Serious? So good, all of you. Okay, so you are in both group. Later I just have to remove you once you go back to physical, okay? So I message to both of you my 2K, all the notes that I already sent for them last week. Okay, so don't worry about it. You can copy later. Boleh Okay. Okay, Jing Heng got one question. Just now Jing Heng was asking what, teacher, can we say atomic size instead of atomic radius? Can Can? For period 3 can. Not a problem. It's the same size and radius. Understand? Okay. Now let's go to what is the usage of this semi-metal. Okay. Who are semi-metal? If you remember, I show you this one. See? The staircase. All the one in the staircase are semi-metal. Correct? Not? So what are the usage? Why are called semi-metal? Okay, the key is this. They have the characteristic of metal. They also have the characteristic of non-metal. Yeah. In between again, you're right. Okay? Now, so if you look at silicon, it's a semi-metal. We know it's a non-metal, right? In a way, right? So it's very poor conductor. But very funny, when you increase the temperature, right? It can start to conduct electricity. See? From a non-metal, now it becomes like a metal because it can conduct electricity. But only when there's temperature increase. So you all see when you use your phone or not, you talk on the phone for very long, what will happen is you burn your skin, right? Because only when you use very long, the temperature increase, conductivity have to increase because more information coming in. Now, the same thing, we use it to make microelectronic industry. All your chips, I told you just now, microprocessor, your microchips, right? Okay, what other elements are very important? The two things I want you to remember is called P-type semiconductor, and another one is called N-type. Okay, I don't really study in very detail in semiconductor. You can go and do your own research more about it. The only thing I need to teach you is when silicon dope with who, get P-type. When silicon dope with who, I get N-type. So I need to make you remember lah. So what to do? I say BP. Boron one is with P-type, BP. BP, you know the petrol station, right? Okay. Then if I have silicon, this is N, AN. Why? A arsenic or A antimony, I also can make N-type. So I put like that, no student can forget one. You won't go and have others. BP, N. BP, N. Sure boleh. Correct or not? Okay, you add this in your notes. I don't know whether you all copy already or not. It's all in my group chat, not personal, okay? I send until this note. If you haven't copied, can you agak see how many pages? Because I'm going to continue a little bit more. Serious. Okay? So these are the metalloid. Okay, just extra info lah, like you're happy, you all learn so much in the periodic table, right? Oh yeah, where do we use it, teacher? So look, if you look at transition metal, the one that we talk about in the middle, in our periodic table, the short ones here, these are transition metal. Okay, there are a lot in our electronic part. Yeah. Okay, copper, all this used for wiring, right? In our casing, we use carbon as well. We use nickel. On our screen, we got a lot of silicon oxide, because that is the glass we use to make smartphone. You can see silica plus aluminium oxide. That's the glass we use. Got rare earth element, That's why we told you already, right? Phone, don't put near your skin. If you really read the smartphone, they give you, when you buy phone, they give you your manual. Do you all read every page? Seriously, who does that, right? Okay, my husband does that. Okay, yeah, he likes to read manual one. Okay, the engineer thinking. So there is one verse inside that states that it shouldn't be 0.5 mm near your skin. So boys, can you please don't put near where your pockets are? Yeah, you put too long after burn your balls. I'm not kidding. And girls, don't put like that, like the auntie, put inside. Scared people maybe pickpocket you, you put inside your baju. Don't do that, Don't put it near your skin. Got rare earth element means these are the things that will cause cancer. So when you sleep, don't put near your head. The radiation also. You are not sleeping well, because a lot of what? You study chemistry, right? Everything also got positive, negative charges, all got electrons running around. You don't believe me? Then why you study chemistry? So you know you're not resting well if a lot of electrons moving. Why, teacher? The phone not moving, what? Hello, when you're sleeping, still got information coming in there. Correct or not? Titi, tutut. So now you understand? So don't put near your head, okay? Yeah. So now we go to the next part called 4.6 transition element. Where are transition element? Guys, look. It's the element between group 2 and group 13. All the shorty, okay? All the shorty, all right? I'm not kidding you, okay? Except for these 3 last one. Look at the yellow one. So according to IUPAC definition, transition metal is an element who has a D subshell. Okay, you forget about all this, okay? You only study this in lower, either A levels or Form 6. The only thing I want you to see is this part. Zinc and cadmium, here, first two, on the shorty, it's still the shorty, okay? They are not transition element. But mercury is. Okay, why? You remember teacher Joyce said got mercury 1 and mercury 2? Anyone got more than one number 1? Yes. More than one number 1, usually they are transition element. We have 10 elements in each of the series. And yes, guys, they are all metal. That's why we call it what? Transition. Sometimes we call it element. Sometimes we call it transition metals. Get it? Okay, write down the date. Today's date. 17/7. Wow. Okay, 4.6, right now. Transition metals. Okay. Don't draw the periodic table. Don't be silly, okay? I want you to do this. Do like that. Draw like me. Write these last three. Write down zinc, cadmium, and mercury. Zinc and cadmium, put cross. Mercury, yes. All these under this are transition metal. Write down. No need to copy everything, just draw like that only. Enough. Settle. Done. You draw a small one, who asked you draw so big one? You think what? Ask you to write all the elements. No, just the shape. Draw big enough that you can write zinc, cadmium, CD, and Hg. Okay, you don't do anything, I didn't want you to copy this one. Okay, I think all of us know, as long as they are metals, they have this characteristic. Okay, very high density. They are very hard. They are shiny. We call it lustrous. Ductile. I always say like my hand, you see, can bend. Ductile means can be bent. Like wiring, wire, you can bend. Malleable, I use the 2L, like a bookends like that. See, you clip it so it can be flattened. That's why this metal, we can use it to make sword, knife. High electrical or even heat conductivity. Heat also can. If electric can, heat also can. Metal right up. High melting boiling point. Now, these are common metal. Even it's not transition, it is metal, you still have all these characteristics. You learn that in lower secondary. Today, adding the word transition metal, they have 4 more special characteristics. Okay? I call this, I call this 3CO. 1C, colorful. Okay, very colorful one. 2C, form complex compound. C has catalytic properties. 1O, got many oxidation number. Variable means banyak jenis. Example, in my list, who got 2 different number one? Can I will tell me? One example. Got 1, got 2, or got 2, got 3 one. Come, tell me. One example.
Copper.
Copper. We got copper 1, right? We also got copper 2, right, guys? Correct? Yeah. One more. Weng Li? Who else? Got number, different one in our,
Iron.
Iron, so we got Fe2 plus. We also got Fe3 plus. So guys, it's true. All those I give you in my list got 2 number one, right? They are transition metal. You don't believe me? Check your own periodic table. See that? So the 3C is colorful. Okay, let me tell you where you find color, okay? I'm sure you all know, right? Red ruby, right? Green is emerald. You know Wizard of Oz? You see everything green color one? That is Emerald City. This is amethyst, purple, right? Sapphire blue. If you watch Titanic, you know, the lady don't wear anything except the blue sapphire, very big piece, we say. Okay, maybe the boys are not looking lah. Okay, So the boy's looking at other place, okay? Okay. So that is Titanic, all right? Really, they found that gemstone so big, I tell you. So you see, right? Why gemstone? Gemstone is this stone. But why are they so precious? We call them precious stone because they come with very interesting colors. Why? Because these precious stones inside have transition element in it. Even chromium has 3 colors. See? Right? Some has more, like vanadium, you see, got 4. So you just have to remember a few only. Like ruby is red, sapphire is blue, emerald is green, amethyst is purple. Why? Because red is due to the chromium. But chromium got more than 1 color, see? Got green also. Ready, go. We always have chromium one. Blue, Titanic is made of iron, but still go down, right? So it's titanium and iron. See, so easy, right? And then I said, manganese sounds like amethyst. So if they ask also, is this few lah? They won't ask so rare one lah. These are the common one. Understand? Okay. Then look at this one. If I tell you zinc, zinc, you see, I tell you, teacher Joyce say zinc is 2 plus only. I say 3 plus, 4 plus, got don't have lah. So zinc is not a transition element. Get it? So it must have more than 1 oxidation number. Then we call them transition metal. Okay, these are the examples. Wow, teacher, what is this, man? Okay, I also learned how to read this only when I was in university. Last time when I was in Form 4, Form 5, my teacher also never teach me. But it's quite interesting to know how to read it, you know. I'm going to teach you guys, okay? Okay, we all know tetra is 4, right? Hexagon is 6, right? Correct? Okay, so amina, just like I told you all, ammonia, NIA, is NH3. Am I right? Then I tell you all, ammonium, NH4, right? So now I have amine. 2 only. From the end onwards, this is NH2. So you see, those amina, NH3, they also will put 3. Sometimes they will be coming in 2. They got different name one. Okay? Done. Copper is copper 2. So you see how I do, So tetra is 4. 4 amine. Amine is your NH3 in this case. Right? 4 is tetra, amine, copper. 2 link to the positive. 2 plus. Hexa, amine, hexagon, 6. Read from the back. Hexa, amine, chromium, 3. Hexa, aqua. Water is aqua. Aqua means water. Cobalt, 2 plus. Ferret is Fe, ferrum. Cyano is cyanide, Cn. So you get hexa is 6. Cyano, ferret, 2. See that? So complex, right? But do you know who is the center metal? The center metal are all our transition metal. Only transition metal got this characteristic, can like what we call octopus like that, okay? Catch so many things put together one. Understand? And the last one, this is the catalytic properties. Okay, so what is a catalyst? Catalyst is like enzyme lah, but enzyme can only happen in living things, right? Okay, catalyst is a substance that speed up the rate of reaction. Okay, it does not change chemically after a reaction. It will maintain the same. So catalyst we can use again and again and again and again. Okay, almost all manufacturing plants means in a factory. You know, right? Factory is either you save time, okay, or you save money. Then only you can earn more money, ma. So they will always use catalyst to save time and save money. All right? Okay, now I'm going to tell you how to remember this. After this, you have to answer before you go, you know. You cannot answer me, you cannot go, you know. So you pay attention, Okay, I'll call your name, Okay. Haber process. I want you to remember. Haber process start from letter H. Is to make ammonia. Got a lot of H, right? It's to make ammonia. I want you to remember, Haber sounds like harbor. You know, in a harbor where we park our boats, Okay, we call dock our boats. We don't call park lah. Parking is for car. We will have all the iron rods so that we can anchor it down, right? So remember, iron powder is for Haber process. Can? Okay. Contact process. I want you to remember, contact, we use hand. To touch something is called in touch, right? Contact, right? So we are so afraid to touch this most acidic acid, which is sulfuric acid. You know why? H2SO4. Is it HCl, 1H only? HNO3 also 1H only. This sulfuric acid is double one. So contact process is to make what? Remember, you don't want to contact with sulfuric acid. So when you don't touch it, you are the victory, okay? Victory! Vanadium 5, okay, oxide, O. Vanadium 5 oxide. Okay, so remember all the things that I do, I use hand. So I don't know how to draw very well lah, but I will draw lah, I'll try out, okay? See, I draw. You remember vanadium 5 oxide. Okay? Okay, nickel, I want you to remember, nickel is used to make shilling one. Make coin, right? Your mother give you a coin, ask you, please go and buy some margarine back. Buy margarine. So nickel is to buy margarine. So remember, it's to manufacture what? Margarine. We turn oil into solid oil. Okay, margarine is like butter, okay? But butter is made from milk. Margarine is made from vegetable oil. Okay? Platinum. Okay, this one a bit hard, so I make fun of it. You know, Oswald. It sounds like Walt Disney. Walt Disney make a movie called Nitric Acid and won the Platinum Award. So Platinum is an award. Who won? Walt Disney. Oswald process. Why do I teach something funny like that? Because then you can remember. And next thing is, you know, exam only come out objective question, right? What is the catalyst used in Haber process? Haber. Did I say what? Sounds like what? Haber. Oh, iron rod. See, you can remember already. Then I say, oh, what we use platinum in which of the process? Platinum award. Oh, Mr. Walt Disney. Walt Oswald. You go and find the answer you can get already. Can you see that? Clear? And that is the ending of the whole entire chapter 4. Easy, right? So today, all this will be your notes. That is your homework as well. You have to copy this. Okay, just now I know you're right until here, isn't it? Okay, then you didn't do anything already. I know I didn't give you time to do. So what I'm going to do is I'm going to take photo of all this. I'm going to send to your notes. That will be your homework as well. Okay, before we go off, take out your workbook, everyone. Turn to chapter 4, page 31. Take out your workbook, please. Page 31. Okay, 31, do until 40. That's it. 31 to 40. Every day, do 1 page of my homework. Okay, so homework 31 to 40 on our workbook. Okay, so everyone, now I'm going to take photo of these notes, the characteristic. If you are not in the group, you don't get my notes now, please tell me before you go off. Okay, so class dismissed. Thank you very much. I'll continue to take photo for you so that you can actually copy the notes at your leisure time. But by next week, I'll be discussing all the homework already. Make sure you do some of it. At least the objective, you finish it. Okay, all right, bye-bye.
Thank you, teacher.
I'll send, don't worry. Bye-bye.
Bye.